Okay, chapter 3, quadratic function. A quadratic function, you have a form fx equals to ax squared plus bx plus c. Here we will discuss more about the maximum and minimum point of the quadratic function. And before that, you need to know that the constant a is very important for the quadratic function. If your constant a is positive, then you will have a graph you will have a quadratic graph like this. So the point here, the lowest point in this curve is known as minimum point. Okay, if your constant a for the x squared is negative, then you will have your quadratic graph, quadratic curve. And this point is the highest value in both x and y. So you will have a so-called maximum point. This one also known as maximum point. Of course, for positive constant a for the x squared and negative constant a for the x squared, you will have a minimum and maximum value in your quadratic curve. And you also have 3 cases for each positive and negative a. So this is how they look like, 3 cases. So this is your y-axis, this is your x-axis. And for minimum curve, quadratic curve, so you will have this part A, and you will have this part B, and of course you have this part C. Okay. Revise from a previous chapter. Then this is you have 2 distinct roots. So b squared minus 4ac bigger than 0. This one you will have one equal same root. So it's a b squared minus 4ac equals to 0. Of course, this one you have no roots. No roots. 1 roots same. And this one you have 2 distinct roots. And this is of course equals to, this case is equals to b squared minus 4ac smaller than 0. Same with the quadratic curve with constant a equals to negative. No place, so I just separate into 3 cases, so it becomes smaller. So this is y, this is x. In here I put in 2 cases. So for first case a, you have 2 distinct roots, 2 distinct roots then your case is b squared minus 4ac bigger than 0. And another one is b case. Let's say here you have b squared minus 4ac equals to 0, 1 equal roots. Okay, the last one also the same. Let's say should be point this way, x, so this one no roots. Here I want to add some extra. The no roots means no real roots. Even you have roots, the value of the roots is imaginary. So no real roots. So b squared minus 4ac smaller than 0. So this is some properties of the quadratic function. Okay, to practice how to draw the quadratic curve with a given quadratic function. So there is a hint, there are several of hints how you want to draw it. Well, let's say I give you using back the equation that we used in the previous lecture, chapter 2 of quadratic equation. Fx equals to x squared plus 5x plus 6. Okay, if you have if your a constant is having some value bigger than 1, let's say 2, 4, 5, then you need to divide, you need to factor out. So I use a simple quadratic equation. Okay, so to solve this, first the a here is positive, so it's a minimum graph. It's a it's a quadratic graph with minimum value. So it's a smile face. And then to find out what is the minimum value of this quadratic equation, so you need to use the techniques completing the square. Of course, later you study the after you study the differentiation, so you no need to use the completing the square. So how you going to do it? Your x plus divided by 2, 5 over 2 square. Of course, here if you have x plus 5 over 2 square, your x plus 5 over 2 square actually is equals to x squared plus 5x plus 25 over 4. So this one you see here is you need to remove the extra value. So from here you minus 25 over 4, then you plus 6. So the completing the square, x plus 5 over 2 square minus quarter. Okay, the second one, if you want to find the minimum value of the quadratic equation inside the quadratic equation, so make this equals to 0. X plus 5 over 2 equals to 0. So your x is minus 5 over 2, minimum value. And after you find what is the x equals to minus 5 over 2, at minimum value, the x is equals to minus 5 over 2, negative. So how about the fx? How about the fx? You still need to find the fx. So what is the fx? I put a question mark here. So your f, you use the x minus 5 over 2. So it's equals to negative 5 over 2 plus 5 over 2 square, then minus quarter. So it's equals to negative quarter. So this is the second part Okay, also like you need to find the minimum value for x and y. So this is the first part, determine whether the graph is minimum or maximum, is a smile face or curve, the unhappy face, another way around. Okay, so the third point is, if you want to draw graph, you need several indicator. The third point, what happens if your f(x) f is equals to 0? You need to find the intersection point. Intersection at y-axis. So what happens if your x is equals to 0? So your f0 equals to 0 square plus 5 times 0 plus 6, so it's equals to 6. And for the last one, what happens if your fx equals to 0? You need to find the intersection at x-axis. Sometimes it can be called as a root. Also known as roots, or sometimes they also might have no roots. So to determine whether they intersect at the x-axis or not, so you can use a formula inside part of the formula inside the quadratic formula. So b squared minus 4ac equals to, okay, so this is a1, b5, c6, so is 5 squared minus 4 times 1 times 6 equals to 1, bigger than 0. So you have two distinct roots, b squared minus 4ac bigger than 0, two distinct roots. Okay, this is a very simple quadratic equation, so no need to use the minus b plus and minus square root b squared minus 4ac divided by 2a. Of course, you want to use it also allowed, but I just do it in this way. X simply factor out. You have plus 6. Of course, plus 6, how to become 6? 6 times 1 minus 6 times minus 1. Of course, here you have a positive, so there is impossible. You use a minus sign here. So plus. Of course, 6 times 1 you will get 7x, so not correct. So of course it's 2 and 3. Two distinct roots. So your x is equals to minus 2 or x is equals to minus 3 when fx equals to 0. Okay, so now I wrap part of the work and then jot down all the information to simplify the information. So first, you determine this is a minimum point, a quadratic curve with minimum point. So of course it's a smile face, the pattern of the graph. Second, your minimum point is minus 5 over 2. And y at the minimum point, the x value, this is the x value, this is the y value. Okay, when your x is equals to 0, intersection at y-axis, y equals to 6. When x equals to 0, intersection at y-axis. Okay, for x-axis, you have minus 2 or x equals to minus 3. When your y-axis is 0, when your fx is 0. So this is a very important information. So these are the 4 guidance you need to draw the quadratic curve. Okay, now we start to draw the graph. Because it's -2 and -3, so I will move my y-axis more to the right. So this is my x-axis. So this is -2, this is -3, and okay, I maybe need to lengthen a bit for my y-axis. So this one is 6, because you need to what we call that, pass through the intersect y-axis when x equals to 0. So here is 0, and here you have -5/2 where the minimum point located, and you also have quarter. So after you have all this, you just label, put a cross here, put a cross here, okay, put a cross here, and then please label because your scaling might not be accurate. So 5/2 quarter, and well, here also label, so you know that this is your, well, my drawing might not be so good, so this is how you draw it. Well, this is how you draw your minimum point. Okay, this is the minimum case, minimum case for quadratic curve or function. Okay, also sometimes if you have time, if you have spare time, you can label, write out the equation in your graph. Fx equals to x squared plus 5x plus 6. This is how you solve the quadratic curve of a given, how to draw the quadratic curve of a given quadratic equation. Okay, to find the range inside the inequalities, range inside inequalities of quadratic function. Still the same. First thing you need to know that whether the constant a inside the x square is positive or negative. So for the first case, if your a is positive, and you will have a quadratic graph which have a smile face. Okay, let's say it look like this, and then let's say here just assume as a minimum point. Of course this is not so important, this part, and I want to label when y equals to 0, the point intersect at x-axis have a value of a and also b. Okay, so to find the inequalities, you have two cases for this quadratic function minimum curve, where you have ax squared plus bx plus c, fx. So okay, for fx bigger than 0, okay, fx bigger than 0, here is 0, bigger than 0 here, and then you need to see the range above the x-axis. So that means the answer for the range for this case is smaller than a, x smaller than a, and what here, this one become going towards the more negative, this one going towards to more positive, so x bigger than b. So this is the answer. Okay, so now the second part, if you have for fx smaller than 0, that means you need to see this part here until here, see the range between the curve. So you will see from here go to here, then stop. So that means your x must be in between here, so smaller than b, but your x also should be bigger than a from the horizontal axis, come to here, so bigger than a. So this is the answer. Okay, so if let's say now you have a second case, you have a for the x squared is negative. Let's say your fx is equals to minus ax squared plus bx plus c. So you will have a quadratic curve fx x, when of course here is the maximum point, not important also, but when fx equals to 0, that means your what we call that x pass through the c and d. Okay, now we have same for first case for fx bigger than 0. Okay, we are looking this part here, from here to here, then stop at these 2 points. So that means you cannot bigger than d. If bigger than d, your range is here, so that means become fx smaller than 0, and you also cannot smaller than here, because it also become the fx, this part the fx is smaller than 0, this one is fx bigger than 0, the two regions same as here, also bigger than 0, smaller than 0, the fx bigger than 0, smaller than 0, the fx here. Okay, so for fx bigger than 0, your x must be bigger than c, that means come to here, from negative to positive, but need to be smaller than d. That means your moving range is from this point to this point only. Okay, now we talk about second case for fx smaller than 0. Smaller than 0 means this part. That means here, the negative, the x go to here, become more and more negative. Here, in another way, the D region, the x here become more and more positive. So you can see x, the answer is x bigger than, smaller than c, the first thing, and x is bigger than d. So this is this is the cases to show to find out the range inside the inequalities of maximum or minimum quadratic curve lah. Press like, share and subscribe button if you like this video.